We are going to see analog to digital converter interfacing with 8051 microcontroller in this video. As you all know, analog to digital converter means analog devices are converted into digital form. Temperature, pressure, humidity, velocity, etc. are the few examples of physical quantities that we deal with every day. So today's world is analog. Analog means continuous in nature. As you all know, ADC has got n-bit resolution, where n can be of 8, 10, 12, 16 or even 24 bits. So higher resolution ADC always provides a smaller step size, where step size means smallest change that can be produced by an ADC. So let's see the pins first. Here we have used ADC 0808 or 0809 chip. This 0808 chip has got 8 analog channels. Here analog channels are represented by IND0 to IND7 pins. These are the analog inputs. These analog inputs has to be converted into digital output by means of D0 to D7 pins. So D0 to D7 are the digital output pins. Then as in all devices, ADC 0808 also contains ground, GND and clock and VCC. Then we have V reference plus and V reference minus. V reference plus and V reference minus are used to set the reference voltage. V reference minus means ground and V reference plus means 5 volt. Then ALE means address latch enable. Address latch enable is used to latch the address. Then SC means start of conversion. This SC is same as write WR pin of other ADC chips. Then EOC means end of conversion. End of conversion is same as INTR pin of other ADC chips. OE means output enable, which is same as read pin. Then here you can see ABC. ABC are the 3 address pins. These 8 analog input channels, that is IND0 to IND7, are multiplexed and selected according to these 3 address pins ABC by means of analog channel selection. So you can see analog channel selection first. If we are providing 000, IN0 is selected, then 100, IN1 is selected, then 010, IN2, then 110, IN3, 001, IN4, 101, IN5, 011, IN6 and 111, IN7. So you have to first select which analog channel you are going to use in your program. These analog input channels are multiplexed and selected by means of these address lines A, B and C. Let's see ADC interfacing with 8051 now. As you all know, this is the block diagram of 8051 and this represents ADC 0808 or 0809. Here you can see plus 5 volt as the V reference plus. Now we can see V reference plus is given as 2.56 volt. Then you have 8 analog input channels IN0 to IN7. Then you have a clock V reference minus which is connected to ground. Then these 8 analog input channels are multiplexed and selected by means of 3 address pins ABC. These address pins are directly connected to P2.0, P2.1 and P2.2 respectively. Then you can see P2.5 is connected to output enable, P2.6 is connected to start of conversion. P2.7 is connected to end of conversion and P2.4 is connected to ALE. Crystal oscillator pins are connected by means of crystal oscillator as well as a capacitor and is grounded. Then steps to program ADC 0808. First, as I have already told you, you have to select an analog channel by providing bits to A, B and C addresses according to analog channel selection. Then you have to activate the ALE pin. Here you can see clock pulse provided. Then first you have to activate the ALE pin. A low to high pulse must be needed to last the address. So first ALE has to get a low pulse, then ALE has to get a high pulse to last the address. So activate the ALE pin, it needs an low to high pulse to last in the address. Then activate start of conversion by a low to high pulse to initiate conversion. Here you can see start of conversion which is same as WR, which also requires a low to high pulse to initiate the conversion process. Then monitor end of conversion to see whether conversion is finished. High to low output indicates that data is converted and is ready to be picked up. Here you can see end of conversion which is same as INTR, which requires a high to low pulse. So high to low pulse output indicates that the data is converted and is ready to be picked up. Then next, activate output enable to read data out of the ADC chip. So an low to high pulse to the output enable pin will bring digital data out of the chip. Here you can see output enable a low to high pulse which will bring the digital data out of the chip. So you can take the data here. Then you can see address pins also here we have denoted. Then you can see the program associated with the ADC. First you have to initialize all pins. Here you have already seen pins are connected to various ports. That you have to initialize first. So ALE bit P2.4, output enable bit P2.5, start of conversion bit P2.6, end of conversion bit P2.7, then ABC bit connected to P2.0, P2.1, P2.2, then data EQU P1. That means it acts as a constant value. So we have provided data EQU into P1. Since we are connected this digital output pins to port 1.0 to port 1.7. So I have initialized it as data EQU. EQU means it is a constant to port 1. Then I have started writing my program. After initializing all these pins, I have started writing my program. First, I have to make this data pin, that is this P1 port as an input port. So by writing this instruction move data comma hash 0FFH, I can make this P1 an input port. Then you can see various pins associated with the ADC. First you have to set this end of conversion pin, because end of conversion pin requires a high to low output in order for the data to be converted and ready to be picked up. So first you have to make this end of conversion signal an input by making a high to low pulse. So set B EOC will send a high pulse to end of conversion. Then ALE is cleared, SE is cleared, output enable is cleared, because these all request a low to high pulse in order to last the address, in order to initiate the conversion, in order to bring digital data out of the chip. So these pins are cleared first. Then I have called out an analog channel selection. So here I have selected IN1. You can see here C is cleared, B is cleared and A is set as 1. Here you can see 1, 0, 0. So I have selected IN1. So IN1 channel is selected. Then I have called for a delay. small delay has been called. You have to mention the delay program there. Then I have make ALE high. That means in order to latch the address, a low pulse as already I have mentioned. So low to high pulse to latch the address for ALE. So ALE will be latching the address by getting this signal. Then a small delay has been called. Then set B SC. Here already low pulse has arrived. Then here high pulse also arrived. So a low to high pulse will initiate conversion process. Then a delay has been called. Then we can clear this ALE pin and we can clear this start of conversion. As you can see here, a low to high pulse for initiate the conversion, also a low to high pulse to latch the address. After this, these pins are cleared. Then you have to check whether the conversion process has finished or not by writing this instruction JBEOC. EOC means end of conversion. You can monitor end of conversion signal to see whether conversion is finished or not. Conversion is finished or not can be modified by using high to low output. High to low output indicates that data is converted and is ready to be picked up. Here jump on bit. If there is bit, it will stay here. If there is no bit, it will go out of the loop. So a low output indicates that data is converted and is ready to be picked up. Here you can mention it as JNB EOC comma here 1. So here you have to wait until it has been done. If it has done, you can read the data, digital data out of the chip. So here I have already cleared by OE pin. Here I have already cleared my OE pin. A low to high pulse will bring digital data out of the chip. So here I have set B OE. Set B OE means high pulse. So an RD read pin is already enabled. You can read the data out of the chip. Then a small delay has been called and that data I can send it to accumulator by means of instruction move a comma data. Then this output enable pin is cleared. Clear this read pin for the next time. Then for conversion, you can write ACALL conversion. Here you have to write hexadecimal to ASCII program, and for making this display, you can write ACALL digital display, that means LCD program. So these are the main program associated with the ADC. Here for delay you can write delay program, and for conversion you can write hexadecimal to ASCII conversion program, that is same as division program. Then for data display you can write LCD program. Then only this ADC program may finish. So in this so far we have been discussing about ADC interfacing with 8051 microcontroller. First we have seen ADC chip, then we have gone through ADC interfacing with 8051, then we have gone through the steps associated with the program for ADC 0808, then we have seen the program. Hope you have understood this video. Thank you.